Hi everyone. Today we'll discuss about violin plot in our studio. Violin plots are used when you want to observe the distribution of the numeric data and are especially useful when you want to make a comparison of the distribution between or among multiple groups. So the peaks, the valleys, and tails of each group's density curve can be compared to see where groups are either similar or different. Moreover, additional elements like box plots, quartiles are often added to volume plots in order to provide additional ways of comparing these multiple groups. So today we will discuss about how to draw a violin plot using our studio. So as usual, the violin plot, box plot, and most of the time graphs are preferred to use the ggplot function. So you have to incorporate this ggplot function into your studio. By this way, you can just draw very easily your violin plots. So in order to save time, I already imported my data frame, and data frame is this. It contains genotype and aggregation, two factors with three levels of genotype and two levels of aggregation, and the response variable here is the grain yield or GY. So you have to run to your studio, and in order to convert those factors, that means the genotype and aggregation, you have to use absolute factor as usual. Also you can refer my previous tutorial regarding to changing numeric or integer into factor. So let's draw the basic violin plot. You can give any name that you want here. I give here WAC, and you have to use function ggplot2, and you have to refer is the data name is aku, as you see here, and also the axis x should be the genotype, and also y should be the response variable, and you have to use a geometry violin function. So type all this one and submit to your studio, then run work. Yeah, let's zoom in. Yeah, as you see, here is the genotype Howie, the genotype Malka and order, and here is GUI is the y-axis. By this way, you can also draw your basic violin plots. Moreover, if you want just to rotate this one, you have to use the function the chord flip. So we already create this formula. This work is represent ggplot as to this. So if you add work plus the coordinate flip, it will rotate the violin plot in this way. And again, if you want to set a trim argument, you have to say it's also false. So by default, this one is true. So if you say false, trim will be displayed into our violin plot. To do that, you have to function ggplot in similar fashion to the previous one. So its data name axis is genotype, the y-axis is the grain yield, and the geometry violin, and also here you have to add trim equals to false. The default is trim equals to true. It does not display the trim. So type this one and run. Yeah, it's already incorporated the trim in the upper and lower part. Then again, also you can select, especially if you want to display the two varieties, let's say the order and Howie, as well as if you want to remove Melka, you can choose the level of the factor that you want to display. So type work plus scale, and this discrete function you have to limit to order and Howie, so to remove the Melka genotype from the display or from the violin. Yes, it's already order and Howie, because we here designated to remove the Melka genotype. And again, furthermore, you can add also the summary statistics. So in order to do that, we already create this work. So you have to use a function stat summary, and also the function y, which is equal to the mean, and the geometry that you have to use is the point and shape, which is equal to 23, the size is equal to 2. So if you type this one it will add the mean pointers to your box plot. Yes, this points indicate that is your mean value. And again, also it can add the median point. So you can use a similar function y is equal to median. Here is y is equal to mean, but all things are the same. Also, you can give any color types that you wish to display. So tap this one and run. Yeah, this is the median point on the Violin plot. And additionally, we can also add the median as well as the quartile. So to do that, work already designated in the form of work. Then here is you have to add the geometry box width, which equals to 0.2. So this will add the median quartile. Yes. And again, also you can create the trim is equal to false. So type K, for instance, here, and you have to use the ggplot function. And also, as here is ACU is our data name, x is the genotype, y is the response variable, which is grain yield, and trim this one. Then it will give K is the value of K is this one. Yes, this one. So we'll add some mean as well as the standard deviation. To do that, you have to use the function start summary, and here is mean plus or minus standard deviation. So melt is equals to 1, and the geometry is crossbar, and the width is you can increase or to 0.3, 0.4 on your preference. So type this one and run. Yeah, let's say this here is 0.1, the width of this bar one. So if we type to 0.1, somehow become 10. And again, also you can make more attractive. So you have to use K, what we designated here, start summary, and the mean as well as plus or minus standard deviation. And also here is the color is red. Yes, by this way you can also, because in this the geometry is a crossbar, but here the geometry is what in a point range fashion. So by this way you can also add the median as well as the quartile range in our studio. Furthermore, we can also add the Violin plot with dots as well as also with jitters. So in order to add the dots, K, what we give, the K means in short form, ggplot, K means in short form, this one. So instead of typing this large syntax redundantly, it is better to represent in the form of K. Yeah, so here we come, let's come here. K, in order to add the dots, K plus geometry dot plot function, which helps us to add dots in Violin plot. So the binary axis is Y, and the stack there is called center, and the dot size is 2. You can also add, or you can also increase or decrease your dots size. Yes, here is the dot size is somehow good, and also you can also increase up to 4. Let's say it's 4. Yeah, on your preference. And again, also let's add the jitters. So again, K plus geometry jitter is a function that helps us to add the jitters. So shape which equals suggesting the position which equals position jitter around 0.2. So type this one and submit to our studio. Yes, so jitter also added to the Violin plot. And then let's change the color of the Violin plots, especially by using the line colors. So let's assign a new name, work22, and ggplot, ACU, the x-axis is genotype, the y is the grain yield, the color is a genotype. So, and genotype Violin trim is equal to false. Then run this one. Yeah, there are different type of color. This is automatically generated because we assigned here is color is equal to genotype. That means give different color for different genotype. So by this way, you can automatically change the Violin plot colors. And moreover, if you want to add your own preference, or just if you just want to add color manually, you have to use the three things. One is the color palette, the other one is the blur color palette, which is found in the blur package, and also the grayscale one. So WAC 22 already designated here. And then you have to say WAC 22 plus scale color manual, and we have three levels how we make and order. So we have to give three different names or color names. So type this one and run. Yes, this is my preference. If my preference is in this way, I can assign manually the color types. And moreover, if you want to use the blur color palette, so you have to use WAC 22 plus color blur function, and the palette is dark too, let's say for instance. Yes. Moreover, I can also use the grayscale. So to do that, WAC 22 plus scale color gray function plus 10 classic. Yes, still it is attractive and beautiful. And also, sometimes you can also use a single color. To do that, you have to use the ggplot function, and the name of the data is ACU, the axis is genotype, the y-axis is the grain yield, the geometry Violin trim is equals to false, and to fill these two colors, and also the geometry box plot width is equals to 0.1, and here is the 10 is minimum. So type all this and run. Yes, this is all are what the same color. The same color. If you want to display on to use a single color, you have to use this one. And again, also you can change the Violin plot with by groups. Let's say, for example, WW is I give WW to this entity plot, and here is the data name. The axis is a genotype. The Y is a grain yield. The field is a genotype, and this one. So type this and run. Let's see it. Yes. Again, here is the field with the field means inside one. That means here is somehow different color from this one, and also this from the others. And again, if you want to change the Violin plate, especially the field one, you can also add manually. You can also use the color palette, color palettes, as well as the grayscale. So WW, what I send here, and we are just focusing here is for what, for the field one, and the color that you see the inside part. So type this one because I already have three levels. That means how we make and order. If you have six one, you have to indicate by comma and also add your color preference. So type this one and run. Again, it brought with a new color or with a new field. Furthermore, you have to use the Brewer color palette. So you have to assign WW plus scale field Brewer, and the palette is dark 2. So type this one and run. Yes, still the field is with different color. And lastly, you have to use the grayscale. So to do that, you have to use this syntax. Yes. And in case if you want to change the position either in the top or in the bottom, and also if you want to remove, so you have to use the syntax. For instance, if you want to display the legend in the top position, so here is the WW plus the 10. WW is what we assign here. WW represent all this function. So sorry. So the 10 and the legend position is the top, so it will display in the top. Yes, it's displayed in the top. And again, if you type this one the bottom, the legend position will be in the bottom. It will appear in the bottom. But if you use the legend position as none, it helps to remove legend from your violin plot. Yes. Yes. Moreover, you can also change the level of the factors, especially, for example, here is Howe, here is Melka, and here is Oda. So if you want just to bring Oda in first place and Melka in second and Howe in third, so you have to use the function scale dot create and limits C which equals to Oda, then Melka, and Melka followed by Howe. So type this one and run. Sorry, yeah, it's already changed. Malka become the first place and followed by, Odas become the first place and followed by Malka and Howie. Let's draw the finalized or the customized violin plots. For example, here is we have to use this all function in one. That means the data name is Aku, then it's followed by the axis is X, which calls genotype, and the Y axis or the response variable here is the grain yield, and the function that helps us to display this violin plot is the geo underscore violin function, and trim is equals to false helps to have this and these extremes, and also field which equals to the gray is a type of color that field inside the violin plots, and also the lab means the title of the x-axis, so you have to here is you can give the title means it will be displayed over the violin plots, and X is the genotype. It will be available here in the x-axis, and Y is the name of or the label of y-axis. So here is the grain yield. The grain yield is in terms of what? In terms of kg, so kilogram. So, and finally the geometry box plot that display here is will be the width which equals to 0.1 and plus the term classic. So select all this one and run. Yes. Yes, so Wagjura is displayed over the violin plot, and the x-axis is the name is genotype, and the y-axis is a gradient in terms of kg. And if you want to change the color by groups, so you have to use here is xx, and you have to use the function ggplot, and here is the data name is Aku, and the x-axis is the genotype, y-axis is the grain yield, and the field is equal to genotype, and also is a function that helps the geometry violin trim is equal to false, and the geometric box plot at display here is the width is 0.1, let's say 0.2 in order to increase the size, and the field, this field will be white, and the lab, that means the x-axis title, the overlaid title, as well as the y-axis title. So type all this and run. So let's see, let's add xx, or additionally you can also plus term classic, but to reduce some complexity, so xx plus term classic. So type this one and run. Yes, still it is very attractive, and also the box plot also is represented in this graph. And finally, you can also add the colors to your box, to your violin plot, especially if using the continuous color. So in order to use the continuous color, xs plus scale fill blur, then the palette is blue, and add theme classic. So type this one and run. And furthermore, if you want to create a discrete color, so you have to use scale fill blur, and the palette is dark too. So type this and run. And again, also if you want to create the gradient, so you have to use a scale fill blur, and the palette is RDBU, and here is a 10 minimal, then run. So you will get these attractive colors. So if you have any question regarding to my tutorial, you can address me through my email workjiratasfound@gmail.com as well as YouTube comment box. Thank you for watching. Have a nice time.